Sine law applications. Question 8. Bald eagles nest in inaccessible areas. A nest of bald eagle was spotted at an elevation of 40 degrees from the foot of the mountain. After climbing 150 meters up a slope of 30 degrees, the elevation of nest was 60 degrees. Find the height of the nest from the base of the mountain. Okay, let's first sketch and see what the scenario is. Let's say that's the base of the mountain, and initially, so there's a slope of 30 degrees. Let's say climb 30 degree slope. So after climbing 150 meters up a slope of 30 degrees, let's say this is 150 meters up the slope of 30 degrees, the elevation of the nest was 60 degrees. So let's say, well, so let me draw like this. So if we climb this much and then this, okay. So from here, the elevation angle was 60 degrees. So from here, the angle of elevation was 60 degrees from here. Correct. So this is 60 degrees. And initially, the angle of elevation is 40 degrees. So let me draw the initial angle of elevation of 40 degrees. This was 30 degrees, let us say, and let's say this is our 40 degrees. Okay, so that's kind of our diagram where let me write down this as 30 degrees, correct? That is a slope of 30 degrees, and that is 40. That means we are left with 10 here. 30 plus 10 is 40 degrees, is the angle of elevation to the top of the tree. And let's bring down a perpendicular from here like this, correct? So that is okay. Now this angle is 60 degrees from here, 60 degrees from that spot, and this spot from here to here is 150 meters. So this is 150 meters for us from here to here, right? Let's call this point A as the base of the foot of the mountain or the hill, and then you walk 150 meters to reach the point B. From B, the angle of elevation for the nest is 60 degrees, and let's say this point is C, the nest, right? And then we can draw in here, and that point let it be D, and let this be from the bottom of the hill, let this be E, right? So that is a figure. So a nest of bald eagle was spotted at an elevation of 40 degrees. So from here, this angle is 40 degrees, 30 plus 10, from foot of the mountain. After climbing 150 meters up a slope of 30 degrees, so 150 meters is that slope AB, 150 meters, this is meters, not degrees. Okay, the angle of elevation of the nest is 60 degrees. Find the height of the nest from the base of the mountains. That means we have to find the height CE here, correct? So what we can do is we can do a construction here also. So let's say this point is O. Now that will help us to solve a couple of things. And now let's go back and see. We need to find what CE is, right? So to find CE, we can find CD plus DE. Now DE is same as this height, right? So that means BO, correct? So these two are equal. To find BO, we can use this right triangle with an angle of 30 degrees and 150. Sine of 30 will give us that BO, right? But to find CD, we need to find that side, which is BC. Now to calculate BC, we need to work with that triangle, which is not a right triangle, and so we can use sine law, correct? That's how sine law comes into place. But to use sine law, we have one length, we need to find the angle opposite to this length. So that means this angle. Well, this angle can be calculated, yes. And once we know this angle, then the problem will be simpler. We can find this using the sine law, correct? So that is how we can work. And there are a couple of ways to find this angle with the line. It makes 60 degrees. So what we can do is we can draw a parallel line here, correct? So we know two things about this angle. First thing is total angle. This is from base 60 degrees. So this from here to here is 60 degrees, right? The same as this. Secondly, if I extend this line, correct? So this is 40 degrees here. So that is going to be 40 degrees, correct? No, this is 40 degrees. Sorry. So the angle of elevation is 40 degrees. That means with the horizontal, the angle of elevation is 40. The total is 60, so that becomes 20. Let me correct this. This becomes 20 degrees. And therefore, this angle here is 20 degrees. This vertically opposite angle of 20 degrees. Okay? So I hope you get it. The thing is, the angle of elevation is 40 degrees. So if I draw my horizontal here and extend this line, then the angle of elevation is 40 degrees, correct? From this point, the angle of elevation is 60 degrees. So with the horizontal, this total angle is 60. That means 40 plus 20, right? So this angle will be a vertically opposite angle, 20 degrees. So we have this triangle ACB, and in that triangle we worked out that the angle ACB is 20 degrees, correct? So we'll start from there. I hope you understand all these calculations, correct? So we say, well, angle ACB is 20 degrees. This angle is 10 degrees, and we know this side of 150 meters. Therefore, now we can use sine law. Let's consider the triangle ABC, right? In triangle ABC, we are trying to apply the sine law. We know this angle and that side, and what we need to find is CB, right? So we say, well, CB over, if this is CB, the angle opposite to CB is 10 degrees over sine 10 is equal to known side of 150 meters over this angle which we calculated as 20 degrees, sine of 20 degrees. Correct? So that is the sine law, and from here we can find what CB is, right? Okay, so we'll now CB is equals to 50 over sine 20 times sine of 10 degrees. And we can calculate this and get our answer. So we get 50 divided by sine of 20 times sine of 10 degrees. So we get 25.385. So we get 25.3856. So let me write this as 6. Okay. So that is CB for us. Now once we know CB, and that is 60 degrees, we can find CD using sine theta, correct? So sine of 60 degrees is equal to CD over CB. That implies that CD, this height, CD is equals to, CB is 25.386, 25.386 times sine 60, right? That is equals to, so we times sine 60. That will give us 21.984. Okay, so we know CD now, right? To find DE, we can use the triangle ABO. So let's consider triangle ABO, correct? That is a right triangle where 30 degrees is the angle, hypotenuse 150. So we can again use sine 30 is equal to OB over hypotenuse of 150. And therefore we can write OB equals to 150 times sine of 30 degrees, which is 150 times sine of 30 degrees? 75. So that is 75 meters, right? So OB is 75 meters. So the total height of this nest will be CD plus DE, right? So the height of the nest equals to this plus this, which is 25, well, let's call it 25.4 plus 75, let us say, right? So we'll add 25.4, 25.4, well, anyway, 100.4, right? 100.4, so it's approximately 100 meter, right? So that is the height of the bald eagle's nest in this particular situation, okay? So that is how we are going to do these kinds of problems. So the critical thing here is to draw a neat and clean diagram. Well, I had a limited space, so I've drawn a very small diagram here, but I should have made a bigger one. And then figure out the angles. So best way to find this angle is to use these two angles of elevation, right? So basically you find this is the difference of these two angles of elevation, correct? Makes sense. 60 minus 40 gives me 20, right? So that's how we get this angle of 20 degrees, and then we use sine law in that triangle to find the length CB, and then we had the right triangles to work with to find the two heights, and we added them to get our answer. So it is 100 meters. Thank you.